I'm a teacher from the school. Is it civil engineering? Is the civil engineering
Thank you very much, Ron, for the kind introduction. First of all, let me say some things about this lecture. First of all, thank you very much for the invitation, Ron. It's a pleasure to be here with you and to speak about some sustainable mobility. My name is Ron Silva, as he told you. I understand that it's difficult for you to pronounce Ron Silva. It may be kind of tricky for you, but if you need to ask any questions, you can use the equivalent in English. It's John, so just treat me for John. It will be just fine. I was talking with two of your teachers, two of your professors a while ago, and I told them, wow, it's kind of difficult to do a presentation when you don't know what kind of students you have. So I had to prepare a general presentation with very broad things, but I think you'll like it. I hope so. If you need, you can interrupt me, you can ask questions, you can participate. It will be a pleasure to try to help you here. I hope you're liking Portugal. Yes, you're very lucky with the weather. The weather brightened up in the last week or so, so give it good use. Well, now that everybody's getting seated, I'll start with the class. Just 1 or 2 moments. Just one more thing. My English is not very, very good. It's kind of rusty, you know. I don't speak English normally in the classes. So forgive me if I stop sometimes because I'm searching for the correct word. And you can help me, of course. But as I understand, you're all very good in English, very intelligent, so you can make up for that thing. Now for the presentation, we'll talk about mobility and sustainable mobility. What's the basic concepts and the basic things. But first of all, let's have a general impression of the last developments in terms of modes of transportation and how people transport themselves. This is a very nice graphic here. I hope you can see it well. I can turn off the lights if you want, but I'm not sure if everybody wants it. But here in this graphic, I try to show you with the mouse. We can see some trends. It goes up to 1999, so it's 20 years late, but that's not problematic because the last tendencies are almost the same. But it goes back to, let me check it, 1850. So quite the statistics that we have here. Well, let's start with some of these lines and the lines, how they move, and let's see the latest tendencies in terms of movement and how people do their travel. So let's start with the ocean. I understood some of you went to the sea already, and as you can see here, the number of people that travel by ocean is steadily going down. It has a peak here around 1900, but not very peaking, and now it's going a bit down. So here, with the light blue, we have the air transportation. Air transportation, of course, was non-existent in 1850, and it started to take off around here, 1950, after the Second World War, and now air transportation is clearly on the rise. As for the rail transportation, the rail, as you know, it started earlier than the air, and it has a steady rise. It's almost like a straight line. It's this black line that you can see right here. This green line, line that's here, it started in 1910, 1920, and it also has a nice rise, not so linear as the rail, but it also is increasing. Now, at the red line, wow, this red line is really, it seems like it's really moving very, very fast. What is this line? This line represents the automobile transportation. The number of kilometers that we do using cars. So after 1950, I would say, 1940, it's increasing almost exponentially. So it's very, very steep upward movement. Now, let's see what's this line that's going down after maybe about 1910. It's starting to decrease. This line is the combination of walking and cycling. So people walk less, people travel less by bicycle. So these are the tendencies that from the 1900s to 2000 and 2013 that we have. This is a general situation. Well, this general situation has consequences. Some of them are good, some of them are less good. Let's see some of them that we have here. Well, traffic jams in some situations, in some cities. I understand that most of you have heard about this. Environmental problems, unhealthy lifestyles, lack of public spaces. This is generally important in old cities like we have here in Europe, in the American continent, in North America, USA, Canada, Australia. They have newer cities, so they are programmed for the car use. But here in Europe, most of our cities were built way before automobiles existed, so the city spaces are very scarce and can't accommodate generally the cars. This causes uncontrolled urban expansion and a lack of social equity. Now, this is the vicious cycle that we are in. I like this diagram very much because it explains in a very clear way how we come to this and how this mechanism feeds itself. So it's like a cycle. Let's start with the first line, the dark blue line. Here, more people choose the car. So if more people choose the car, we have more cars. We have more road traffic, and if we have more road traffic, we have more traffic jams. We have a lack of parking spaces, and as a consequence, the bus, the public transportation, has more difficulties. They have difficulties with their schedules, and they have difficulties in capturing passengers. So they are less attractive. If they are less attractive, of course, that the operator of the public transport, he doesn't want to lose money, so he takes some buses out of circulation. So there's a decrease in public transport offer. Let's see what happens environmentally. It's here, this line. There's an increase of air pollution, noise pollution, and also some accidents, unfortunately. So the city becomes a city that's less pleasant to live in. So the inner city residential areas become less attractive and have less population, and the population starts to move to the outskirts of the city. In terms of employment, urban employment areas are less accessible, and so the employment possibility moves to the outskirts of the city. Sorry about that, I wasn't supposed to move that quickly. So, what's the common response that we have had until, say, 1980, 1990 in most parts of the country? Okay, to try to solve this problem, this kind of situation, politicians usually invested more on the road. But if you invest more on road and parking, you're not resolving anything, you're just aggravating the problem that you already have. Sorry, but I have a problem here. Let's show this one like this, because the animation is not very good. So, sustainable transport system, what it is, let's see some basic concepts. So, a sustainable transport system allows all the population to move around, to do their voyages in a sustainable manner. Sustainable manner that won't be bad for the environment. It is also affordable. It should be affordable so that all people, even the ones with less money, less financial resources, can move around and do their trips. So I have to animate this again. And also, a sustainable transport system has to limit its emissions in order to be good for the environment and not to decrease the quality of the air and the quality of the spaces. So, you need to find the right balance between three things: the economy, the environment, and social equity. These are three pillars that you have to consider when you do transportation, mobility, sustainable systems. So in this presentation, we'll see 11 things, 11 aspects of the mobility and sustainability. The first one is energy use in transport. The other is greenhouse emission, other transport emissions. We'll also talk about that a bit. Injuries and fatalities, movement of people, movement of freight, and the last 5 ones: urban land use, length of paved roads, household spending, relative transit costs, and energy intensity. Let's start further with the first one, the energy use for transport. As you can see here, we have the European situation and the use of energy, and you can see that the transport makes up for about 1/3, 33% of the total use of energy. So it's quite a big chunk of energy that transport systems are using, that the transport sector. Actually, it's in individual terms, it's the biggest one. Households come second with 27%, industry comes third with 24%, and services 13%, and agriculture just 2% of use of energy. So the sector of these sectors considered here, the sector that has more energy consumption is in fact transport. In the transport sector, we can see here in this graphic what's the general use of energy and also its evolution. Here, the biggest chunk of it, the biggest portion, is this green one, and this green is road transportation. So as you can see, from 1990 to roughly 2010, it's steadily increasing. Of course, it has a peak here that coincided with the economic problems. Now it's slowed a bit, but it's if you consider from 1990 to about 2008, 2009, it's almost a linear increase. And it's the biggest one, as I told you. This one is aviation, the yellow one. So it also has increased. And this one is the navigation, maritime situation. So let's talk a bit about the greenhouse effect now. Let's go to the second point of it. Well, greenhouse effect. I suppose that you already heard a lot about this, so I'm not going to go into too much detail. It's not necessary. Probably you know more than this than I do, so I won't go into great detail. But a sustainable transport system should limit the emission within the planet's capacity to absorb it. Of course, this is a very nice phrase, but the question is, what is the capacity of the Earth to absorb emission? That's a more controversial aspect, but let's leave it aside. What we can take into the future is that we have to limit our greenhouse gas emissions in all sectors. And of course, since the transportation sector is a very important sector in terms of these types of emission, we have to try to limit them as much as possible. So, as it says here, transport contributes with about 1/3. This is very proportional with the energy aspect. So, if you burn fossil fuels, you also have emissions. And the cartoon that's on the right, it's a very funny cartoon, but it shows one important aspect. People don't like changes. People are creatures of habit. So they have their habits, and they want to stick to their habits, and they don't want to change them. Maybe some people only change if they are forced to change. If they're not forced to change, they think, oh, I'm just one, what difference does it make? It won't make any difference. I want to continue to drive my gas guzzler, my big SUV, my big car. The other ones, that's okay, just me. Well, we can't think like that because everybody thinks like that and we're not in a very brilliant situation, so we have to change it. So, if these emissions are in decline, we progress towards sustainable transportation. Now, this is another cartoon to show you the greenhouse effect. As you can see, we receive radiation from the nearest star, that's the sun, of course. And if we have these greenhouse gases, the emission can't go back to space, so it keeps refeeding the system, and then the Earth starts to heat sometimes, sees somewhat, and we have all this crazy kind of weather, and it's not good, of course. So, worldwide emissions, greenhouse emissions by sector. Here you can also see another aspect, it's a very interesting graph that shows the contribution of the various sectors to these kinds of emissions. Greenhouse, we have roughly three kinds of gases. We have carbon dioxide, that's CO2, we have methane, and we have oxide nitrous. I guess it's like this, but you would say it in English. But anyway, here are the formulas. So we have CO2, carbon dioxide, that's roughly 77%, and this is a contribution from transportation, 13.3%. So it's quite a big contribution. In the transportation sector, the road is by far the biggest contributor, with almost 10%. Then we have the other gases, and we also have the other industries: electricity, heat, land use, agriculture, waste. The other gases are methane, that's CH4, and nitrous oxide, that's N2O or NXO. It's about 8%, but the biggest one by far is CO2. So let's see how much CO2 does some transport modes do for passenger by kilometer. Well, starting here at the bottom of the scale, we have a large SUV. It's four-wheel drive. It's very big, and it's only carrying one person. So in this case, we have 0.44 or 0.44 kilograms per person and per kilometer. So if a guy does 10 kilometers, we have 4.4 kilos of CO2. Well, of course, this is the worst kind of situation that we can have. If we have an average car, it gets better, even if it's close single. It just has 0.32, so it's a much better situation. But if you start using the car a bit better, or having carpooling, you start to divide the kilograms of CO2 for more persons. So this ratio gets lower and lower and lower. If you use public transportation, it's really very low, as long as the public transportation doesn't go only with the driver, of course, but in a normal situation, it's much better. And if you cycle and walk, you have zero. So this is the best situation of all. So in terms of transportation and greenhouse impact, there's nothing like cycling or like walking. It's the better situation. Here you have another aspect. These two graphics, the one before and this one, they are very similar. So you can see here that in fact the SUVs, sports utility vehicles, I think you know what kind of vehicles I'm talking about. If not, please interrupt me. SUVs, just with the driver, is the worst situation, and of course the bicycle or walking and the bus 3 and 4 is full is also a very good situation. But solo driving or one car with one person is not really a very good situation in terms of energy consumption and also greenhouse gas emissions. What about other gases? We only, up till now, we only speak about greenhouse gas gases. There are three: carbon dioxide, nitrous oxide, and methane. But there are other pollutants that are also important and have unhealthy consequences. These other pollutants are carbon monoxide, solvents, benzenes, sulfur dioxide, and others, and solvents. Well, here, this situation has improved quite a bit. It has improved mainly due to the new technologies that vehicles have nowadays. So nowadays vehicles have extremely clean combustions, they have good anti-pollution mechanisms, so this situation improved. But nevertheless, we need to, if we don't travel by the car, it won't pollute nothing. These systems on the cars, they work very, very well, but in one condition. The car has to have its servicing done. You can't run the car for 30, 40 miles and not take it to the service. Of course, the car has to be in shape, and the engine has to be hot. When the engine is cold, the anti-pollution mechanisms, they don't work that good. Okay, so this is an important data. Car pollutes almost the same in the first kilometer and in the next 20 or 30 kilometers. Okay, because the anti-pollution mechanism, if it's not at the correct temperature, it just doesn't work. It doesn't trap these pollutants. It dumps them in the atmosphere. Okay, now injuries and fatalities. Well, I could make about 50 slides of this if I wanted, but I guess there's no need for that. Everybody knows this. So if you have transportation, road transportation, rail transportation, bus transportation, this kind of activity, you have a risk. So if you have a risk, unfortunately, sometimes things don't go that right, and you have injuries and fatalities. Of course, the situation has improved, particularly here in Europe and also in the United States, because the roads are better, because the cars are much better, much safer, but nevertheless we have some casualties, so if we travel less, we should have less casualties. So this is the movement of people. I'm not going to take too much time here because we talked about this already. And this is the movement of goods. And here in this graphics we can see the evolution of the movement of goods. 2005, 10, 5-year intervals, and of course these are estimatives, they are forecasts. We don't know if this forecast is correct or not. We'll have to wait till 2030, then we'll see if it's okay or not. But as you can see here, it's steadily increasing in all sectors. The biggest sector here is the yellow one. The yellow one is light-duty vehicles. So there's a big movement of goods using light-duty vehicles. In terms of rail freight, that's one of the most environmentally friendly forms of transporting goods. As you can see, it's almost invisible. It's this pink or this magenta line here, but the percentage is very, very low. The air one, this is a very pollutant way to transport goods. That's the red one. It's increasing. The road one and the freight trucks, this yellow and this green, they're also increasing. But somehow we don't see increases in the best ways to transport goods, best ways in terms of pollution, of course. So the tendency is not so good. Well, in terms of urban land use, we can also establish some connections here between the way that we organize our territory, we organize our cities, we organize the places where we put the buildings and the services and the households and the residential areas. There's a very good connection between this and the energy that we use on our transportation. So, a sustainable transportation system should minimize the use of the land. Therefore, we should have more concentrated cities. If we start to spread out, we start to have ways to waste more energy. Because if we're very spread out, public transportation systems don't work that well. We have low density areas, so in low density areas they are not economically feasible, so they don't work that well. And you have urban sprawl, you have very low densities. Therefore, the cycle of car dependency increases with this kind of land occupation. So a more concentrated, a more compact use of land is better for the environment. What about the length of paved roads? Well, the basic conclusions that we have in all studies is that the more lengthy the roads are, the more pollution you have. Because if you build more roads, you have more opportunities to travel. So people travel and they use energy, and of course they pollute the environment. Well, what about household expenses? I have two graphics to show in this part 9, the household transportation spending. This is the first one, and it uses Canadian data. I have the next one, it uses European data. So, according to this Canadian data, that was the one that I could find that I thought it was appropriate for this section. Here, from 1992 to 2002, you can see that the amount in Canadian dollars that each family uses is increasing. And this amount in dark, in light blue, is the amount spent in private car using. The amount here in white is the amount spent in public transportation. So you can see here that for the Canadian situation, they spend much more on private cars than they use on public transportation. I guess this is, of course, this is a Canadian situation. They have a very big country. They have very low land use. So, situation here in Europe, it's not very similar, not the same, but nevertheless, it shows similar tendencies. Okay, so this is the European situation, and here you have several countries. I don't know why, but Portugal is missing. Maybe we're too good for this. So here you have transport systems, services, operation of personal transport equipment, and purchase of vehicles. So you have the three kinds of expenses that the household makes. They have to buy a car, they have to buy gasoline or diesel for the car, and of course they have to do the maintenance of the car. Here you can see that these countries, Hungary, for instance, UK, they have very high expenditure in vehicles. These kind of countries here, like Poland, like Greece, they expend less in their vehicles. Oh well, this cartoon is another cartoon that I find very, very funny because it illustrates a situation that you have nowadays. So here the guy says he's stuck in the traffic jam and he says, I hate driving, but I need to work so I can pay the car. Then he gets to work and he says, oh, I hate my job, but I have to work to pay for the car. So what's the logic between this? It's really very funny. But this takes us to the equity situation. Transportation, if it's very cheap, of course lots of people use it, lots of people try to use it, we have traffic jams, and then nobody can do it because the roads are all too full. But if it's not affordable, if it's too, let's say, too expensive, then the socially less privileged classes can't use it, so it's not so good. So we have to strike the right balance here. We have to have equity in the use of this. Well, let's talk about one of the main reasons that people prefer to drive their private car than to drive the bus or to go in the bus or to go on the train or other public transportation system. It's because when they do their analysis, their mental analysis, they take everything out of the equation except the cost of the fuel. Let me explain in other words. When they think about doing some trip, a 30 kilometer, 60 kilometer trip, they just think, okay, how much money will I spend in the fuel, in the gasoline or in the diesel? And they forget about all the other costs of the car. The maintenance costs, the buying of the car, the insurance of the car, the inspection of the car. They don't put that part of the expense in their personal analysis. So if it's just gasoline or just diesel or compressed gas or whatever, eventually the car, it gets cheap and they choose to ride by car. Okay, let's talk about the energy intensity. We talked about this a while ago, but let's view it from another angle. Of course, the type of car that you drive has a very notorious impact on the fuel consumptions. So if you can drive less polluted vehicles, or vehicles that are more energy efficient, that's the better. Generally, the vehicles that are better in this aspect are small vehicles, of course. The more mass you have, the more consumption you have. This is quite true in urban driving, because in urban driving, you're accelerating, stopping, and each time you stop, the energy goes to zero. The kinetic energy of the car, it's transformed, energy is never lost, you know. So when you hit the brakes, what you do is you transform the kinetic energy and heat energy on the brakes of the vehicle, so you lose it all. So the more mass you have, the more energy you are wasting in urban driving. In highway driving, it counts, the mass doesn't count that much, but the size of the car and the shape of the car is very important for the aerodynamics. Cars and trucks account for almost 75% of all the transport industry use. So, to have a perspective and to put this in numbers, the energy that's in 1 liter, for instance, 1 liter of gasoline, most of it is wasted. I don't know if you have this information or not, of this knowledge, but this diagram is very good to show you how much of this energy is wasted. So here we have 100%. So 100% represents the total amount. Of that 100%, 17% is lost in idling. So you stopped waiting for it to go and you lose almost 17%. 62%, that's a big number, 62% is lost in the engine by heat. The engine heats, so that's energy that's lost. That energy is not used to move the vehicle. It's just to heat nothing. 2% in accessories and operations. So when we turn on the lights, we turn on the ventilator, we turn on the air condition of the car, and we lose a bit more of energy. Then the transmission, the gearbox, the differentials lose by another 18.2 and 12.6%. So what percentage is used? 12.6% of it. So you put in 1 liter of gasoline and only 1 deciliter is used. The rest is lost, totally lost. Okay? This is quite an interesting view for you to see how much energy we waste in transportation and in private vehicles. So, what kind of vehicle is the perfect one? I guess you know because you just need to view it. Well, the perfect vehicle after many years of investigation from the best universities in the world is this one. It's a 4-wheel drive, could go anywhere. Of course, it's temperamental. You need a special driving license to go in these vehicles, but it's a way. It's a sustainable green 4x4 off-road vehicle. Of course, if you like something more comfortable, you also have this kind of vehicle that's a bit more comfortable, and it's better for the weather if you have bad weather, of course. But it's some kind of solution. Of course, I'm joking. No, well, let's go to some practical applications of this. Well, this is the situation on the left. Of course, it's a very bad situation. You don't find this in many cities, but some of them unfortunately have it. And you have to stop wasting energy. We have to stop wasting land space with the cars, because one car, it's about 5 meters long, it's about 2 meters wide, so 5 times 2, 10 meters square. If it's only one person is occupying 10 meters square, and of course we have to take some margins to the left, to the right, to the front, to the rear. So it's quite a bit of urban space that just one vehicle occupies. So if you walk with your bicycle, at least in short trips, it's very much transport efficient. So we need to, what are the challenges? The challenges in terms of public transportation, for instance, are to provide alternatives to the individual vehicle, to the private cars, easier access to services, to cultural activities, social, sports or leisure, savings in the amount spent on the move. The people, the persons, the population has to perceive, oh, if I go by public transportation, it's not so inconvenient and I save some money, so it's good. It reduces the emissions of pollutions, so they have to have quality, they have to have efficiency, availability, speed, they have to be reliable, people have to trust them, comfortable, frequency, and low noise. These two small figures here, I'm trying to put the mouse, but somehow it doesn't work, show how much persons can go in a bus, and if they are not in a bus, they are private cars, all the space, the urban space that they occupy. Therefore, road infrastructure must provide space for pedestrians, cyclists. People from the north of Europe, Denmark, for instance, are very good at this. Poland, Netherlands, also, and other countries. Insurance, social spaces, and leisure. So the infrastructure has to change in many cities. This change is visible from 10 years at least. Of course, in the north of Europe, European countries, they started this quite a while ago. Here in the south, we're a bit later, but we're also starting, so we're on a good way. So it's essential to address the urban environment. It should be requalified, peaceful, and accessible. So it is necessary in some cases, of course, not all, some cases are very good, to redesign the streets as spaces we can live and simple and not just passage corridors. Also, we need to combine different transport modes. For instance, the same ticket goes through Madrid, it can be used in the bus system. That's a very good way to go. And we need to combine several transportation modes. For instance, the park and ride, the bike and ride, the kiss and ride. All these things have to be used. So what are the strategies? And now it's your time to try to figure out, at least for the foreign students, what is said here in Portuguese words. So the Portuguese students may give you a help now. What are the strategies? You go by bike, you go by bicycle, that's what it says here. Use the public transportation, you can walk, and you can share your car. If you have to use your car, at least try to share it, see if somebody, neighbors, does the same trip, and you can agree on a schedule, so you don't have to bring so many cars on the road. So these are some, I'm getting to the final stages of it. We just have 1 or 2 films to see. So increasing mobility comes at a price. that our cities, towns are paying with poor air quality, constant traffic jams, high noise level, pollution. So we need to change this situation. On the other side, oil is increasingly desired and we're becoming obese with all the oil, and the planet is not getting any healthier, it's getting hotter. Short car trips are the ones that pollute more per kilometer traveled. I told you this thing a while ago because when the car is when the engine in the anti-pollution systems that modern cars have nowadays, when they're not at the correct temperature, they don't work simply. So they just let the pollutions pass through them and they go right directly to the atmosphere. And well, not finished yet. We still have two short videos to see, but this is the end of the presentation. Before the videos, I would like to ask if you have any questions. Please feel free to commentate or ask anything. Oh, I guess everybody understood. That's a good sign. Okay, so let's go to the short films. I'm going to turn this one off now.
As populations increase and development occurs, it is becoming more and more challenging for governments to ensure the movement of people and goods. The needs and considerations of global citizens are changing, and clogs up 75% of its mileage in an urban environment. The result? An explosive cocktail of congestion and pollution. Time wasted in traffic jams could soon be costing the European Union 1% of its gross domestic product. Urban traffic is responsible for 40% of CO2 emissions generated by road transport, and 9 in every 10 Europeans are exposed to harmful particle emissions that are higher than the tolerated threshold. However, the European Commission of Transport believes that an alternative and more environmentally friendly air mobility can be achieved through well-targeted actions.
D'abord, la promotion
We first of all need to promote clean fuels and in particular bioenergy in the field of transport.
une directive
The Biofuel Directive lays down that biofuel must replace 5.75% of the fossil fuels used for transport.
aussi basée dans le transport.
Then you have the far-reaching research and development program.
Qui est en partie
This is hinged in part on these new green propulsion methods.
puis j'ai pour
I've also proposed to the European public authorities
collectivité publique
that at least a quarter of new commercial vehicles purchased to new fleets be clean vehicles.
intelligent pour un cas au moins c'est
There
d'achat.
really is a clear determination within them to advocate the use of much cleaner vehicles, electric vehicles, hydrogen vehicles, and mixed propulsion vehicles.
Véhicules beaucoup plus propres, véhicules électriques, véhicules à hydrogène, véhicules à propulsion mixte.
As far as urban transport is concerned, in addition to the financing of equipment and infrastructures, in particular in the new member states, the European Union is backing projects that aim to replace petrol with clean alternatives. And take the example of Lille in northern France. The city has something of a reputation as a pioneer in the field of sustainable and more efficient transport. It was the first in the world to build a totally automatic high-frequency light railway system. Today, this system carries almost 80 million passengers a year. For the past 10 years, the urban community of Lille has been working on yet another new solution, the biogas bus.
Le biogaz, c'est à partir des déchets organiques.
Biogas is made from organic waste in sludge of sewage treatment plants,
C'est produit naturellement.
using naturally produced gas that is then purified for use as a fuel for buses.
Carburant des autobus.
The purification process in question is an innovation. It makes it possible to convert the biogas produced by the fermentation of organic waste to obtain the same level of quality as natural gas. The buses can therefore run on one or the other, which offers a solid guarantee of supply. It's not more expensive to run a bus on gas than it is on diesel, as far as the price per kilometre is concerned, which means that on the whole it doesn't cost the city more to use gas-operated vehicles. It's a real win-win situation. We're protecting the environment without having to dig deeper in problems. Once the development phase was over, the city's projects gathered momentum with the acquisition of new gas-operated buses and the construction of an adapted bus depot. Each parking space is equipped with a recharging socket. When they return to the depot after their round, it only takes a minute for the drivers to plug their vehicle into the automatic distribution network.
Actuellement,
At present, we have just over 200 gas-operated buses, 214 to be exact, from a total fleet of 330, therefore around two-thirds. The aim is to make the entire fleet run on gas and to only have gas-operated vehicles.
que des véhicules.
And so as not to waste this great idea only on the buses, the city now has plans to make its dustbin lorries run on gas. Let's now head for Graz in Austria. Next time you're passing through, don't forget to taste the local speciality, the schnitzel, with a generous offering of chips. You may not be aware of it, but you'll be doing explains, biodiesel can be obtained from a large number of raw materials that are readily available. Da rohstoffe kommt von aus. Raw materials are everywhere, on our very doorstep. They're all around us, whether coarse oil, sunflower oil, waste oils, or animal fats. I usually say as long as we eat machines from utensils instead, we'll have animal fat, which, by the way, is an excellent raw material for biodiesel. Another good piece of news, the equivalent of biodiesel exists for petrol. This is bioethanol and is produced using plants that Europeans grow in large quantities, such as sugar beet or wheat. The European directive has given a serious boost to the use of these biodiesels. In Graz, for example, one taxi company runs its 200 cars exclusively on biodiesel. This takes us to the third stop on our travels, to London. The British capital is one of the most polluted cities in Europe. One of the culprits, friends of vehicle traffic. Here again, the solution could come in part from the famous red buses, or at least from this bus in particular. At present, only 3 of them actually run in the city. At first glance, they don't appear to be any different to the others. But if you take a closer look around the back, what you could mistake for exhaust fumes is nothing more than a plume of water steam. London is in fact one of the European cities that is testing the hydrogen bus in its network within the framework of the European Research Programme.
Nice city, sir.
Okay, so that finishes the presentation. That finishes the presentation. Thank you very much for your attention. For your interest, of course, I wish you all the best and the rest of you stay here in Portugal. I'm sure you're going to like it, so come back when you want, and I'll give the word back.
I have some relevant information for you. Tomorrow is Saturday. All the meals will be served in the Campus Zoom, not in this campus. It's Campus Zoom, where you find a blue painted building near the hotel. When you come to this campus, walking, we see in the left side the blue building. Here, sorry. No. It's a high school, social school. Campus 1. The lunch and dinner will be served there. Okay. Did you understand? Another information. To Sunday, there are sport activities. Tennis and bowling, football. There's enough students to practice this modality. So you only have bowling and tennis. A bus will waiting for you in the hotel at 3:30. Okay, be there. Who wants to go to these activities by bus? It leaves 3:30 and arrives back to 6 o'clock. 5, 6 o'clock. Okay. Today we propose to you to make a pen paper, is a walking paper it's a tour in the city. Each